A minus B. A minus B means write only the elements of A, but it should not present in B. So in our previous classes I said real number is a union of rational and irrational. A rational cannot become irrational, and if it is irrational, then it cannot become rational. To make each of the following a true statement, we have to make it as a true statement. Hello everyone, a warm welcome to one and all. This is your Shruti ma'am lecturing in Vidhyaashram, the Temple of Excellence, Mysuru. So welcome you all to the fifth session of the chapter sets. Let us recall what we have learnt in the session 4. So we have learnt about many operations on set, that is union of sets and intersection of set. What do you mean by union of set? Union of sets is represented by the symbol U. If you have any two sets like A and B, then union of set is nothing but writing all the elements from A or B. That is, A union B is the collection of all the elements such that X belongs to A or X belongs to B. That is, writing all the elements from A and B. Next, what is intersection of set? Intersection of a set is given by this symbol, and if you have any two sets, then intersection of any two set is given by collection of all those elements X such that they must belong to both A and B. So here OR is used, that means the element may be present in A or B, you should list it out. But here when it comes to intersection, the common elements are written. That means element should present both in A as well as B. Also we have learned how to write an intersection and union of any three sets. Also we have found writing the union and intersection of many sets. And in today's class, we'll continue two more operations on set. The first one is difference of set. As the name says, difference means subtraction. When you subtract a given set from another set, what happens? And one more topic, complement of sets. So we'll start with now difference of sets. So what do you mean by difference of set? So the difference of set is nothing but, suppose you have two sets, A and B, then A minus B we say it as, or we read it as A minus B. What does this A minus B gives? So A minus B means the set of all elements belongs to A but not in B. So here I can write the definition. It is a collection of all elements where X only belongs to A but not B. I'll give you an example. Suppose you have a set A is equal to 1, 2, 3, 4, 5. And set B is equal to 2, 4, 6. So what does this A minus B represent? What does A minus B represents? A minus B means collection of all those elements in A which are not in B. That means you are not writing the common elements. You are writing only the elements present in A but not in B. What are the common elements here? We have 2 and 4. So remove this 2 and 4 from A. So you are subtracting B from A. So A minus B. So subtract 2 and 4. Leave 2 and 4 and write the elements. The remaining elements are 1, 3, 5. So see here 1, 3, 5 are the only elements which are in A but not in B. So A minus B is nothing but the same. Suppose I take B minus A. What is B minus A? B minus A means elements must be in B but not in A. We have 2, 4 which are both in B as well as A. So don't write 2 and 4. Write only the element which are in B. What is the element which is only in B? That is 6. So your answer is 6. Also note that A minus B cannot be equal to B minus A. Because when it comes to A minus B, you are writing only the elements present in A. And when it comes to B minus A, you are writing only the elements which are in B. So therefore, they cannot be equal. So we'll take one more problem. Here, A is given by 1, 2, 3, 4, 5, 6. B is given by 2, 4, 6, 8. Find A minus B and B minus A. Let me write A minus B. What is A minus B? The elements which are in A only, but it should not be in B. So, what are the elements which are in A? So, 1, 2 I cannot write because it is also in B. Next, 3 I can write. I cannot write 4. I can write 5. I cannot write 6. So, the only elements which are in A are 1, 3, 5. Next, how it is B minus A? B minus A, again, I cannot write 2 because it contains in A. 4 also repeated in A. 6 is also in A, so I cannot write. So, except that, I can write only the element A because 8 is not in A. So, therefore, B minus A. So, clearly, what you can observe here, A minus B is not equal to B minus A. If you represent this in Venn diagram, so your Venn diagram will be, so this is your universal set, this is your set A, this is your set B. Suppose this is set A, set B, and this is your any universal set. What is elements which are in common? 2, 4, 6. So 2, 4, 6 are in common, so we will write inside the oval. So 1, 3, 5. And here you have 8. So you can see, you can shade this region, only this region, which is I am shading. So this is your A minus B. And this one, only this part is your B minus A. And what is this? This is your A intersection B. So your A minus B is 1, 3, 5, B minus A is only 6 and this. So except the common part, the elements which are in A is A minus B, elements which are in B is B minus A, and this is your A intersection B. Next I am taking one more example. We have V is equal to A, E, I, O, U, B is equal to A, I, K, U. What is V minus B? So V minus B. So remove the common elements A. Next I. So V minus B means only elements of V. So that is E, O. U is also common, so remove it. So only E and O. Next B minus V. Again B minus V is the element K. Okay. So if you represent this in Venn diagram. So this is your universal set, this is your set V, this is your set B. So V and B. What are the common elements? A, I, U. A, I, U is already written inside the circle V. The only elements are E, O. And inside the circle V, the only element left is K here. So again, this part, except the intersection, will give you V minus B. And this part containing only K is your B minus V, and this is your B intersection V or V intersection B. Both are one and same. Okay. So you can observe through Venn diagram also. Now, so as I said now, the difference can be represented using Venn diagram also. So here, this is a universal set. Let this may be a universal set. And this is the circle A, that is elements of A. And this is the circle B, the elements of B. Now, so this is only your intersection part. So the red color here represents only your A minus B. And this purple is representing only your B minus A. Also one more thing, if you take the intersection of any of these three sets, these sets can also be form a subsets. So if you take A minus B and B minus A and A intersection B as three sets separately, and when you intersect them, whether it may be A minus B intersection B minus A, or A minus B intersection A intersection B. So you will get 3 sets. When you intersect any of the 3 sets, you will not get any element. That means what? The intersection of any of these sets is null set. So that is, therefore, they are disjoint sets, whether you intersect. So for example, in the previous case, take the intersection of these two. What you will get? Null set, because V minus B intersection B minus V is null set. If you get the intersection as null set, what does that mean? It means they are disjoint set. You take this one. Suppose you take V intersection B as one more set. What is your V intersection B? It is common elements in both V and U. Take the intersection of these two, V minus B and V intersection. Do you find any common elements there? No. So therefore, they are also disjoint. Again, B minus V and V intersection B. Do you find any common elements there? No. So therefore, they are all empty. So you take intersection of any of these 3 sets, the result will be empty. So therefore, they are all disjoint sets. So here we have taken one more problem. If A is 3, 6, 9, 12, 15, 18, 21, B is 4, 8, 12, 16, 20, C is 2, 4, 6, 8, 10, 12, 14, 16, D is 5, 10, 15, 20. Find all these differences. So first one is A minus B. A minus B means write only the elements of A, but it should not present in B. So what are the elements which are only in A? So only in A is 3, 6, 9. I cannot write 12 because it is in B also. Next 15, 18, 21. So except 12, you can write all the elements of A. Next, we'll take A minus C. So C, A and C. So write only the elements of A which are not in C. So remove the elements which are present in C. What are the elements I can write here? I can write 3. I cannot write 6 because it is in C. Then I can write 9. I cannot write 12. Then I can write 15, 18, 21. So these are the elements, A minus C. Next is B minus C. Subtract B and C. So what is B minus C? So write only the elements of B. So 4 I cannot write, 8 I cannot write, 12, 16 also I cannot write. So the only element is 20. Next, B minus A. B minus A means write only element of B. It should not present in A. So what are the elements here I can write? B minus A means I can write 4, 8, 16 and 20. So 4, 8, 16 and 20. And 12 I cannot write because it is repeated in A. Next, C minus A. C minus A. So remove the common elements which are in A. I can write 2, I can write 4, I cannot write 6, I can write 8, 10, 12 I cannot write, 14 and 16. So next one is D minus A. So you can see D and A here. The only common elements is 15. So D minus A means write only the elements of D but not in A. So you can write all the element except 15. So 5, 10, 20. Next, C minus D. C minus D. So except 10, you can write all the elements of C. So therefore, you can write 2, 4, 6, 8, 10 you can't write because it is repeated here. 12, 14, 16. Next, vice versa, D minus C. So except 10, you can write all other elements. So in D, so 5, 15 and 20. So this is how we will write difference of any two sets. Next, here is one more question. If x is a, b, c, d, y is f, b, d, g, write x minus y. X minus y is elements in x, not in y. Just remove the common elements. So what are the common elements? B and D. So here also B and D. So x minus y means elements in x. So A and C. Next, y minus x, f and g. F and g. So intersection means common elements. What are the common elements? B and D. So now these are again 3 more new sets. So if you intersect any of these one, either this or this, so they are all disjoint. That's why we said that x minus y and y minus x and x intersection y are all disjoint set. That means they all contains different elements in their set. Next, here is a question given. If R is the set of real numbers and Q is the set of rational numbers, then what is R minus Q? So in our previous classes, I said real number is a union of rational and irrational. A rational cannot become irrational, and if it is irrational, then it cannot become rational. So if real number is a set which is a union of rational and irrational, if what is here Q? So R minus Q, what does that mean? This is the real number set. If I remove all the rational number, what I will get? Only irrational number. So therefore, what does my R minus Q represent? It is J, which is irrational number. So similarly, we can say if natural number is a union of even number and odd number. If this is your natural number set, and if you remove all the even natural numbers, then you will get only odd numbers. If you remove all the odd numbers, then you will get only natural even numbers. So this is how we use logical questions when it comes to the sets in mathematics. And remember this, all these are all infinite set. Rational numbers, irrational, natural, whole numbers, integers, real numbers, all are infinite sets. Next, we will move on to the next topic, that is complement of a set. What do you mean by complement of a set? So here I have taken an example. Let U represents the set of all prime numbers. So what does it represent? The set of all prime numbers. So U will be 2, 3, 5, 7, 11, 13, 17, etc. That is only prime numbers. Next, and we take one more set, A. So A is the collection of prime numbers that are not divisors of 42. So they are not divisors of 42. First we will find out what are the divisors of 42. That is prime divisors. So prime divisors of 42. What are the prime divisors of 42? So prime divisors of 42 are 2, 3 and 7. So they can be divisible by other number also, but they are not prime numbers. So the only prime divisors of 42 are 2, 3, 7. But what is our set A given here? It is collection of all prime numbers which are in U, but they are not divisors of 42. So except 2, 3, 7, except 2, 3, 7, it contains all other prime numbers. So then what is this 2, 3, 7? So 2, 3, 7, they are not in A. So the elements which are not in A can be represented by using one more set called A complement. So that is nothing but complement of the set A. So complement is nothing but, if you want a complement, then you should subtract any set from the universal set. So this is how we will denote mathematically the complement of set. So complement of set is nothing but the difference of union and the set. So this is what I have explained here. So we see that 2 is a prime number which belongs to 2, but 2 is not in A, because what is my condition? A contains the prime divisors which are not dividing 42. So 2 divides 42, so therefore it cannot be in A. Similarly, 3 is in U because it is a prime number, but 3 is not in A. And 7 is in U, but 7 is not in A because they will divide 42. My condition is that does not divide 42. So therefore, 2, 3 and 7 are the only elements of U which do not belong to A. So therefore, they can be written in one more set. They can be formed different set, and that set is called as complement of A. So complement of A is nothing but the elements which are not in A. So therefore, they can be written as A dash, and the definition of them can be written as A dash contains all those elements X. All the elements must be in the universal set, but they does not belongs to A. That means they are not in A. So therefore, what is the definition of the complement of a set means? Let U be the universal set and A is a subset of U. Then the set of all elements which are not in A. So this is very important. So not the elements of A are called as complement of A. So symbolically we denote it as A dash, or we can read it as a complement also. So therefore the definition is nothing but U minus A. So when you subtract any set from the universal set, the resultant set is nothing but your complement. So we have a question here. Let U is equal to all the numbers from 1 to 10 and A is the set which contains odd numbers between 1 to 10, and find A dash. We can clearly write, so A dash means what? Elements which are not in A. So that means what? U minus A. A dash is nothing but U minus A. So what are the elements which are not in A in this? So that is 2, 4, 6, 8, 10. So I hope you understood now. So U minus A means write only the elements of U which are not in A. So complement is nothing but what? Elements which are not in A. So if the set A is given, write the elements which are not in A, that becomes your complement of A. Next, let U be the universal set of all students of class 11 of co-educational school, and let A be the set of all girls in class 11. Find A dash. What is U? So students of class 11 of a co-educational school. So U is collection of boys and girls, correct? So U is a set collection of boys and girls. And what is set A given here? So it is set of all girls. So don't confuse, collection is nothing but set. So set of all girls. So then what is our A dash? It is collection of boys. So therefore set of all boys. So A dash is set of all boys of class 11. Next, this is how we will represent a set and its complement. So if this is your universal set and this is your set A, this is your set A, then outside the set A, what does the complement A says? Elements which are not in A, then it must be outside the circle. So therefore here the shaded part represents the complement of a given set. And one more thing is that if A is a subset of U, so any circle written inside the rectangle is nothing but subset of a universal set. If A is subset of U, so then A dash is also subset of U because it is contained in U. So you can take this as an example. Since all the elements of A are in U, what we can say? A is a subset of U. Also, you can see all the elements of A dash. This one is also in U. So, therefore, A dash is also subset of U. So, therefore, if A is a subset of U, then A dash is also subset of U because every element of A or A dash are present inside U. So, here is one more question we are having. U is given 1, 2, 3, 4, 5, 6. A is 2, 3. B is 3, 4, 5. Find A dash, B dash, A dash intersection B dash, A union B, and hence show that A union B whole dash is equal to A dash intersection B dash. So first let me find them one by one. So first question is given as A dash. What is A dash? A dash means elements which are not in A, that is U minus A. Now leave 2, 3 and write all the elements in U. So except 2, 3, write all the elements in U. So therefore it is 1, 4, 5, 6. So this is your A dash. Let me take B dash. B dash means leave elements in B. Don't write elements in B. So what are the elements in B? 3, 4, 5. Except 3, 4, 5. Leave 3, 4, 5. Write only the elements. So that is 1, 2, 6. So this is your B dash. What is my next question? I have to take the intersection of these two sets. So let me take A dash intersection B dash. What is our A dash? 1, 4, 5, 6. Intersection. What is my B dash? 1, 2, 6. What does intersection means? Writing the common elements in both the set. Do you find any common elements there? Yes, we have 1 and 6. So therefore, your A dash intersection B dash is 1 and 6. Next, we have to find A union B. So A union B. So we have A is equal to 2 and 3. B is equal to 3, 4, 5. So what is A union B? A union B means writing all the elements from A and B. So we have 2, 3. Here 3 is already written. So 4, 5. So this is your A union B. Next, we have to show that A union B whole dash is equal to A dash intersection B dash. So this we have already found here. So we have here A dash intersection B dash. Let me take this as equation 1. Now I am going to find A union B whole dash. So here I have A union B. So I want to find its complement. That is A union B whole dash. So A union B whole dash means what? Leave the elements of A union B and write only the remaining elements. So U minus A union B. So now I have U as from 1 to 6. So therefore leave 2, 3, 4, 5. So from 1 to 6 you can write only 1 and 6 with A union B whole dash. So take this as equation 2. Now what is given? I have to show that A union B whole dash is A dash intersection B dash. So therefore you can see here A union B whole dash is 1, 6. Correct. And it is same as A dash intersection B dash because it is also 1, 6. So this is equal to A dash intersection B dash. So from 1 and 2. So hence we have proved it. Next, we have some properties in complement of a set also. You can see here the complement laws here. The first property says A union A dash. So what does A represents? So we have a union universal set and this is your set A. And this one outside the set A is your A dash. If you take the union of these two, what you will get? You will get universal set. Next, if you take intersection of these two sets, we know that A dash means elements which are not in A. A means elements which are not in A complement. That means what? They do not have any common elements. Therefore, they are disjoint set. That is, the intersection of set and its complement is empty. Whereas union of set and its complement is universal set. Next, in previous problem we have proved this. And this statement was given by De Morgan's. So therefore, this statements are called as De Morgan's law. We have proved only one statement in the previous problem, that is A union B whole dash is equal to A dash intersection B dash. And second statement is A intersection B whole dash is equal to A dash union B dash. So this can be said like this also. So the complement of union of two set is equal to the intersection of complements of the sets. And here, so the complement of union of two sets is nothing but intersection of complement of two sets. And here, that is the complement of intersection of two sets is union of complements of two sets. So this is De Morgan's law. Next we have law of double complementation. What does this law of double complementation says? So when you take the complement 2 times, then you will get back the same set. I'll take an example. Suppose you have U is equal to A, E, I, O, U. Let me take A is equal to A, E, I. What is A dash? Elements which are not in A. So leave A, E, I write only O, U. Take the complement again. A dash, whole dash. Take the complement. So what is the complement of A dash which are not in A dash? What are the elements which are not in A dash? A, E, I. What is this A, E, I actually? The set A. So when you take a double complement, it gives back the same set. So that's what the law of double complementation says. Next we have law of empty set and universal set. So empty means what? You have nothing. That means you do not have any elements. So what does its complement implies? Then it should contain all the elements. What is the set which contains all the elements? The universal set. So therefore, phi dash is nothing but U. Similarly, universal set means it contains all the elements. What does it complement means? It should not contain any elements. So what is the set which will not contain any element? Empty set. So therefore, U dash is empty. So here I have taken few more problems now. We have universal set from 1 to 9, A 1 to 4, B even numbers from 2 to 8 and C 3, 4, 5, 6. What does A dash represent? A dash, I'll write it directly. A dash means elements not in A. Leave 1, 2, 3, 4 and write the remaining element. 5, 6, 7, 8, 9. Next, B dash, not in B. So leave 2, 4, 6, 8. 1, 3, 5, 7, 9. Here they have given A union C whole dash. So first find A union C. What is A union C? First find A union C. So your A union C, union of A and C. So what is the union of A and C? 1, 2, 3, 4. So 3, 4 is already written. 5, 6. So you have all the elements from A and C. So union is nothing but writing all the elements from A and C. Now you have to take the complement of this. A union C whole complement. What does complement says? The element which are not in the given set. So now we have to remove all the numbers from 1 to 6 and write only the remaining elements from the universal set. So 1 to 6 you will remove and write only 7, 8, 9. So this is your answer. Next we have A union B whole dash. So before that we will see what is A union B. I'll write the set here again. So we have A is equal to 1, 2, 3, 4. B is equal to 2, 4, 6, 8. C is equal to 3, 4, 5, 6. So and universal set is numbers from 1 to 9 we have. Next, now what is A union B whole complement? So first find out what is A union B. So A union B, writing all the elements from A as well as B. That is 1, 2, 3, 4, 6, 8. Now we will take complement of this. What is its complement? Leave the elements in A union B. So except 1, 2, 3, 4, 6, 8, write only the remaining elements. So we have 5, 6 cannot be written, 7, 8 cannot be written, 9. Next, A dash whole dash. What does law of double complement says? This is equal to A. What is A? 1, 2, 3, 4. Next, B minus C whole dash. Here comes a difference. First, B minus C. Subtract B minus C. B minus C means write only the elements of B which are not in C. So, what are the elements present in both B and C? So, we have 4 and 6. So, 4, 6. Leave 4, 6. Write only elements in B. So, what are the remaining elements? 2 and 8. So, we are not supposed to write B minus C. We are supposed to write its complement. So, let me take B minus C whole complement. Complement means leave the elements of B minus C. Write the remaining elements from universal set. So, 1, 3, 4, 5, 6, 7, 9. So, this is what you will get. Next we have union A, B, C, D, E, F, G, H. Find the complements of the following. We can directly write, we have A as A, B, C. So therefore, A dash, what happens to A dash? So we have one more question. U, A, B, C, D, E, F, G, H. Find the complements of the following sets. The set A, B, C, D is given. Just write the complement of it. So A dash. Leave A, B, C. Remaining D, E, F, G, H. So except these elements, write the remaining elements from U. That will become your complement. So B dash. D, E, F, G. A, B, C, H. Next C dash. A, C, E, G. So A you can't write. B, C you can't write. D, E you can't write. F and H. Next D dash or D complement. F, G, H, A. So B, C, D, E. F, G, H I cannot write. So these are the complements of the given set. So here are few examples. I can write by taking natural numbers as a universal set. Okay. If I take natural numbers as a universal set, write down the complements for the below sets. Then X is an even natural number. I said natural number is a union of even natural number and odd natural number. If this is your set A, then what is its complement? If this is your set A, then what is your A dash? It is collection of all those X where X is an odd natural number. So this will be your complement. Next, X is a positive multiple of 3. So therefore, if this is your set B, then what is your B dash? So here they are saying it is a positive multiple of 3. So what I can write? X is not multiple of 3. Multiple of 3. So that will become your complement of set B. Next, X is a prime number. If this is your set C, then what does C dash represent? So collection of all those X where X is not a prime number. Not a prime number. By taking natural number as a universal set, you will get these as a complement. Next we have X is a perfect square. What is here? My universal set is N. So if this is your set D, D is a set of all perfect square, then what does your D dash represent? The collection of all numbers where X is not a perfect square. Next we have X plus 5 is equal to 8. So if you make it as a solution, so you have X plus 5 is equal to 8. So what is X? X is equal to 3. So here this is the set 3. If you take this as set E, so natural numbers, then E dash contains all the natural number except 3. So this will be your complement. Why? Because E contains 3. Then E dash should not contain 3. So therefore it can take all the natural numbers as a universal set, but it cannot take 3. So therefore I can write it as N minus 3. Next we have X greater than or equal to 7. So X greater than or equal to 7 is your set F. Then what does F dash complement says? So natural numbers means you can draw in a number line. So this is your natural number. It starts from 1, 2, 3, 4, 5, 6, 7, 8. So what is set F here? It is taking all the values which is greater than or equal to 7. So after 7 is your set F. Then what is your F dash? Before 7. So what are the natural numbers before 7? That is 1, 2, 3, 4, 5, 6. Or you can write F dash as collection of all those numbers where X belongs to natural numbers and X is less than 7. You cannot put equal to because equal to implies 7 is there in set F. So 7 should not contain in F dash. So you should write strictly less than 7. That means numbers from 1 to 6. Next question. So here we are verifying the De Morgan's law. So to verify De Morgan's law, first find out what are the complements you can find? So we have two De Morgan's law, union and intersection. So before that, let me find what is A dash, B dash, A union B whole dash and A intersection B dash. First, let me find out A dash, then B dash, then we will go to according to De Morgan's law. So what is A dash? A dash is U minus A. So 2, 4, 6, 8. Leave 2, 4, 6, 8 here. So that is 1, 3, 5, 7, 9. Next B dash, U minus B. What is B dash? 2, 3, 5, 7. So 1, 4, 6, 8, 9. Next, first let me take the intersection of these two sets. A dash intersection B dash. Do you find any common elements here? Intersection, yes, I have 1 in common, then 9 in common. Now let me take union of these two sets. So what are the union of these two sets? 1, 3, 4, 5, 6, 7, 8, 9. So now we have done with A dash and B dash. Next we will go for A union B and A intersection B. So what is A union B? A union B means writing all the elements from A and B. So let me write A union B. So here we have A, 2, 4, 6, 8. So we have A is equal to 2, 4, 6, 8 and B is equal to 2, 3, 5, 7. First, let me write A union B. What is A union B? 2, 3, 4, 5, 6, 7, 8. Now take its complement. Take its complement. So complement means write the elements which are not in this set. So what are the elements which are not in this set? We have U from 1 to 9. So leave all the numbers from 2 to 8. So here you are getting 1 and 9. Next we will take A intersection B. Do you find any common elements in A and B? Yes, we have. What are those elements? 2. So next, take the complement of this. What is the complement of this? Except to write all other elements. 1, 3, 4, 5, 6, 7, 8, 9. So according to the statement here, let me prove the first one. So take this as equation 1, equation 2, equation 3 and equation proof. Now I am proving first one. What does my first statement say? A union B whole dash and A dash intersection B dash must be same. First let me write down what is A union B whole dash. So A union B whole dash, what I got? 1 and 9. Is it same as A intersection? Is it same as A dash intersection B dash? Let me check. A dash intersection B dash is also 1 and 9. So therefore this is equal to A dash intersection B dash. So from equations 1 and 3. Next I am proving the second statement. What does the second statement says? A intersection B dash. What is A intersection B dash says? 1, 3, 4, 5, 6, 7, 8, 9. So is it equal to A dash union B dash? What is A dash union B dash? 1, 3, 4, 5, 6, 7, 8, 9. Yes, they are equal. So this is equal to A dash union B dash. So this is proved from equation 2 and 4. So this is how you are going to prove De Morgan's law. So first write all the sets and its complement. Then check and verify the given equation. They will be same. So draw appropriate Venn diagram for each of the following. So we know that A union B whole dash is equal to A dash intersection B dash and A intersection B whole dash is equal to A dash union B dash. So the diagram will be same for them. So I'll write for A union B. So this is your A union B. So if this is your set A and this is your set B, A union B means all the elements from A and B. Okay. What does its complement represents? This is your A union B. Then how its complement? Elements which are not, then they are outside the circle. So therefore, it will be like this. So if this is your set A and B, then elements which are not in A and B, outside A and B. So This is your A union B whole dash. And this is same for A dash intersection B dash because they are one and the same. A dash means outside the circle A. B dash means outside the circle B. So they will be outside the they will be outside the two circles. Next we will take for A intersection B whole complement. So if this is set A, this is set B. How your A intersection B will be? Only the oval part will represent the intersection part. If it is complement, then except this common part, all others can be shaded. So therefore, your intersection or the complement of its intersection. This is A, this is B. This is A, this is B. So this will be like this. So except this part, you can take all the elements from A and outside the A also. So this is how your Venn diagram looks like for the complement and its set when it comes to union and intersection. Next question. Let U be the set of all triangles in a plane. A is the set of all triangles with at least one angle different from 60. What is A dash? So U is set of all triangles and A is set of all triangles where one angle is different from 60 degree. Set of all triangles where one angle is different from 60. So therefore, what is your A dash? So that is set of all equilateral triangle. So what does this means? If you have a triangle here, they are saying that if A, B, C are angles, either from A, B, C, one angle is different from 60. One may be 60, the other two angles are different. So one angle is different from 60 means if this is 60 degree and this is not 60 degree, this cannot be 60 degree again. So 60, 80. How much it becomes? So what does this statement says? If you have a triangle, if one angle is not 60 degree, if this is not 60 degree, let me take it as 50 degree. If this is 50 degree, then suppose if this is 60 degree, one angle is not 60 degree means other remaining angles can become 60. So 50 plus 60, 110 and this is 70. So what does this mean? One angle is different from 60. If one angle is not 60, then the other angle cannot be 60. But if you have more than two angles as 60, what is the remaining angle? This is also 60. What type of triangle is this? They are all equiangular triangle. So here set A contains all non-equiangular triangles. So therefore your A dash will be, that is complement of this set will be equiangular triangles. So therefore your A dash is set of all equiangular triangles. Now finally we come across last fill in the blanks to make each of the following a true statement. We have to make it as a true statement. So we have learned it already. We'll verify it now. What is the union of a set and its complement? We know that A does not contain elements of A dash. A dash does not contain elements of A. So therefore, when you write all the elements of A and A dash, your result will be universal set. Next, phi dash. So we have learnt the law of phi and u in complement. Phi dash means what? Phi means empty set means no elements. Complement of empty set is all the elements it should contain. That means u. So here this is nothing but u intersection A. So when you are intersecting, A is the subset of u. So when you are intersecting the subset along with its set, your answer will be A. Next we have A intersection A dash. So we know that they are disjoint. So therefore answer is empty. Next U dash intersection A. We know that U is nothing but it contains all the elements. So U dash means no elements. That is nothing but phi. So U dash here means empty intersecting A. Empty means no elements. A contains some elements or they may also not contain elements. So therefore here the answer is empty. So this is all about the difference in sets. So difference means when you are taking the difference of any two sets like A minus B, write only the elements of A which are not in B. And when it comes to complement, this is also nothing but difference, but your difference is from the universal set. So write only the elements of U which are not in A. So therefore the complement and difference of sets are very important. So in the next class, we will take some statement problems or practical problems based on all these sets operation, that is union, intersection, difference and its complement, and we will verify the given statement. So until then, keep watching, keep learning and keep exploring. Thank you.